And I work for ICANN. In fact, prior to ICANN, I was with APNIC for quite some time, and so that's kind of my background. And basically, the objective of this tutorial is to talk about DNS, especially focusing the DNSSEC, and see actually what are the aspects that you would need to know, especially if you want to sign your zones and protect the DNS infrastructures, basically, right? I will try to actually cover some of the basics, just in case if any of you are new to DNS, just a brief overview, and then we can go into talk about more of the security aspects, and then focusing DNSSEC, right? Okay. Also, actually, I would like to acknowledge Rick Lamb, who is ICANN's Senior Program Manager for DNSSEC, and so some of these contents comes from him as well. And also, of course, I would like to acknowledge the APNIC training team as well, especially myself, Shane. We have been working on some of these examples and things like that. So, all right. Now, from DNS basics point of view, so what, as probably you know, that DNS means, what we are trying to do here is to map one resource to another resource type. Okay. For example, mapping a name to an IP address. Even we have something called reverse DNS, where what we do the reverse way around. We try to map a number to a name as well. That's reverse DNS. Okay, so we know that we use DNS on a very regular basis, on a day-to-day, even when we access web, we browse, we send emails and things like that. So we always use DNS in these situations. So it's very important for us when we consider our day-to-day businesses, right? Now, what really happens when, say, for example, if you're trying to browse a certain website, or even if you want to do some DNS query, this is what really happens. Say that you're doing a query in this case, this example. So you're trying to query a web server, which is www.example.net. Okay. So we have this entity called a resolver. Resolver is simply a client in DNS. So we have a resolver, a client. It's sending a request to a DNS server. And in this case, this DNS server is called a recursive server, or what we call a caching server. Basically, we call it as a recursive server because this server is capable of going and talking to many other DNS servers and get the answers or kind of referrals, and so that it can talk to other DNS name servers. Also, it is normally called it as a caching server because when it gets these answers, it keeps the answers in its memory or the cache. So we call it as a caching server as well. So the client sends the request to the recursive server or the caching server. Now, always when we talk about DNS, another important fact what we have to actually understand is DNS has a very organized structure, right? So we have a very organized structure. It's kind of a tree hierarchy, so where we have the root on the top, and then we have what we call delegations. So we have root on the top, and then root level has got delegations to what we call top-level domains, or TLDs. So root has got delegations to TLDs, like, for example, .coms or .nets and .edu and so on. There are quite a lot of those now, because nowadays we have country code top-level domains, or what we call CCTLDs, and then we have generic top-level domains, the GTLDs, and in fact now we have new GTLDs, or new generic top-level domains. There are quite a lot of those. So root has got delegations to all these. Okay, so this is why it's a proper structure, very well organized structure. So always when these recursive servers or caching servers, when they want to actually find certain answers behalf of their clients, they send, or they ask this question from the root servers, because root servers sit on the top of this hierarchy, right? So this is where the recursive servers would go and talk to the root servers and ask pretty much the same question or the query which is asked by the client or the resolver. So in this example, what we are looking for is the IP address of www.example.net, right? When the query goes to the root name servers, now talking about root name servers, there are quite a lot of root name servers scattered around the world, what we call instances of those. There are quite a lot of those as well, close to about 400 something or so root servers scattered around. And so it can go and talk to any of these root servers, or pretty much the nearest one in this case, and then the root server can respond. So there are many of, altogether, if you think about the naming process, there are 13 of primarily of those name servers, which starts from the name of the first one is the a.rootservers.net. The second one is b.rootservers.net, and so on. The 13th one is actually the m.rootservers.net. So there are altogether from A to M. And then we have multiple instances of those roots scattered around the whole world, right? So the query goes to root name servers, and then root name servers, as I said earlier, the root name servers, they have these delegations to .coms and .nets and so on. Now, since our question is about example.net, right? Our question is about, we need to find the IP address of www.example.net. The root server knows that it has got a delegation to .NET servers, .NET name servers. So it will give a referral, it will give answer back to the recursive server saying that obviously the root server do not know the exact answer, the IP address for www.example.net, but it can give a referral to the next level, which is .NET, right? So it will return the IP addresses of .NET, right? And then the recursive server can go and talk to the .NET name servers. In this case, it's a GTLD, which is generic top-level domain, and ask pretty much the same question. What we need is the IP address of www.example.net. So if you consider the same theory here, same concept, now instead of the root server, it is the GTLD server, but GTLD server has got a delegation to the next levels. So for example, .NET, it's here, so something.net or company.net. So all these are delegations coming out of .NET. Because we are asking for example.net, it can give a referral to the example.net name servers, and that goes to the recursive server. So recursive server knows where to contact to find the answer about example.net, and it goes and talk to the example server.net now because it knows the IP addresses, and ask the same question, give the IP address of www.example.net, and then the answer returns back from the example.net name server with the correct IP address of www.example.net. Why I'm saying it's a correct IP address? Because now this type of name servers are what we call authoritative name servers, right? So initially I was referring to recursive name servers, which was in the middle, but these type of name servers, we call it as authoritative name servers because they are authorized to give answers for that particular zone. In this example, the example.net, okay? So they are authorized name servers, authoritative name servers. They can give reliable answers about this particular zone, about example.net here. That's why that correct IP address for www.example.net can be given by these name servers. So example.net can have multiples of authoritative name servers. They can have a primary name server and then multiples of secondaries and so on, again scattered around, wherever it is. And then they can answer back to the recursive name server, and then the recursive name server send this answer back to its client or the resolver, so the resolver gets the correct IP address. So now the resolver can go and talk to whatever the web server it was referring to. So it was asking to go to www.example.net. It has got the IP address now and get the web page. So once this answer is given, the recursive server will keep this answer in the memory or in the cache, right? So this is what we call the caching process. So this is really what's happening in a very simple DNS query. So you can see there are a number of servers involved. We have name servers, different types of name servers, recursive name servers, and then the authoritative name servers, the root name servers, and then, of course, we have our clients. And most importantly, we have that hierarchy of DNS where we have a proper structure, the root, the delegations, and the next levels, and so on, right? OK, so that's some information about the DNS. Also, actually, one more thing over there, which is what we call TTL. TTL stands for time to live. Now, this is, again, the time that can be set in the authoritative name server when we define a mapping. So if we define a certain TTL, right, if we define a certain TTL, this is the time that when this answer goes into a cache, when it goes into this recursive name server, it will stay there for the amount of time which we define in this TTL. Right? So that's the idea of a TTL, or a time to live. All right, so if we consider this whole process, so what are the processes or the flows involved in this whole DNS data flow? Pretty much our DNS infrastructure here, right? So we have our zone files. So zone files are simply kind of administrative spaces where where we define, for example, the references to other name servers and so on. So that's our administrative namespace. Normally, you can even call it as a database, right, or simply as a file if we think from a system or a DNS administrator's point of view. So we write these zone files, and then we have our primary servers, or what we call master servers. We can still update these zone files through another process called dynamic updates. This is where we talk about dynamic DNS, right? And then we have our secondary name servers, or slaves. Earlier I told you, for redundancy purposes, again, especially from a security point of view, it is very important that we have multiples of these name servers. So we have multiples of secondaries. These secondaries can be, again, in different networks, different subnets, different countries even, and so on. Sometimes, again, from a security point of view, we do see that some organizations or some administrators, they tend to put their DNS servers in one subnet or one network, which is not a very good practice, because in case if that subnet is being attacked, for example, you will lose both name servers over there. That's why it's always good to put in two different subnets. Don't put, say, in one subnet, or even if you can actually put in different buildings, for example, because sometimes we can have other natural disasters and so on. So that's a good practice. Or even if you can have your secondary name servers across boundaries, country boundaries, that's also fine. Okay. So we have some transactions between our primary name servers and secondary name servers. When I say transactions, because we have these zones written into our primaries, so this need to be transferred to secondaries because they are identical. They are all our name servers, authoritative name servers. So they should be serving the same data wherever, whatever question that you are being asked from wherever location. They should be serving the same thing. So this is why we have to maintain the consistency. So we have to, have the secondary name servers. Again, we need to set some timing parameters to make sure that these secondaries are consistent with the primaries and they get the information, zone data correctly from the primaries. Okay? All right, and then we have our caches or recursive name servers, which I mentioned to you earlier. They would then go and talk to, if the clients ask some questions from these recursive name servers or the caching name servers, these caching name servers would go and talk to primaries and secondaries, whatever, the nearest ones, and then they will get the answers from the authoritative name servers. So we have our clients who then would talk to these recursive or caching name servers, trying to find the answers. So this is how various flows or the data flows in DNS occurs. Now, there are a number of those here. If you really think about, okay, where I'm not safe, right? We have writing zone files, we have dynamic updates, then we have zone transfers between primaries and secondaries. Then these caching name servers or recursive name servers, they talk to these primaries and secondaries. And then we have clients talking to caches. So there are lots of things happening. But where can, if someone wants to attack, where can it occur? So these are the questions that we have to think about, especially if you are thinking from a security point of view, right? So actually, if you really see, there is no place is safe, right? So if someone wants to attack, they can do in various ways. Someone can corrupt data, right? Someone can corrupt our zone data. Also, there can be some unauthorized updates come from these dynamic updates, through dynamic updates. And then what about zone transfers we discussed? So if I am the primary, if you are the secondary, right? So you would come to me and get my zone or the zone file from myself to yourself, right? So when you come to me, how do you really know whether I am really your primary? Maybe someone can be impersonating me, right? So you would be then talking to a wrong server. Or even when I actually give my zone to you, how do I really know whether you are really my secondary? So impersonations can happen. And then we have caches, right? So the data, the zone data are kept in these caches. So what about if these caches get poisoned, right? If some wrong information goes into these caches, then these caching servers can respond wrong answers. So say we have a website, instead of the correct IP address, if it returns the wrong IP address, the clients would go and talk to a wrong web server. So these are all risks involved in this whole DNS process. And now, if you consider this whole DNS infrastructure, we need to have number of DNS security mechanisms to protect all those aspects. Now, talking about the zone transfers and things like dynamic updates and so on, we have a mechanism called transaction signatures, or TSIG, where we can protect these transactions, right? So that's one of the mechanisms where we can use to protect the transactions, or in other words, servers, because these transactions happen between the servers, like primaries and secondaries and so on. And then the other aspect is protecting the DNS data. That's where our focus is. That's where the DNSSEC comes in, protecting the DNS data. So where does the data live? We have our zone files, we have our caches, right? That's where we have our DNS data. So here the objective of DNSSEC is to protect those so that if we get some answers from those places, and if the integrity is lost, if we can see, when you talk about security, integrity is one important factor, right? If the integrity is lost, we can't call it as a secure system. So what we try to do here with the DNSSEC is to make sure that our DNS data is protected and the integrity is all intact, okay? Now, day-to-day life, you encounter many of those things. You log into many systems, and even in real life, you would travel with your passports, or even when you go to a bank, you would go with your some identity card and things like that, or ATM cards. So you would have lots of security kind of authentications. So even the DNSSEC mechanism is something similar to this. For example, if you want to encash a check, when you go to a bank, they would check your identities, they would check your signatures and things like that, right? So even from a DNSSEC point of view, what we are trying to do is that. What we are trying to do is to make sure that whatever party that we are trying to talk to, we try to understand whether this is the real party. Are we going and talking to the real party and getting the correct information, okay? So where the DNSSEC fits in, as I mentioned you, there are these man-in-the-middle type attacks and so on. So we try to, DNS is vulnerable for those. So we try to actually protect the data using DNSSEC. So DNSSEC stands for DNS Security Extensions, right? DNS Security Extensions. And then, if we can fully implement DNSSEC, we can actually get some confirmation that our data, what we are getting, is not really modified by someone, or it is actually it can be relied upon, right? That's the main purpose. Now, you probably, I don't know whether you have heard about some of the, there has been lots of incidents, but this was one of the very incident which made a big impact, which is the DNS changer. Happened some time back, which created a lot of impact. Many of the machines were infected. For example, your DNS entries were changed so that you could actually go and talk to some different name servers and retrieve different information and things like that. So these are some examples which could happen even in our real life, okay? So if you have a look here, so say we have a bank. Normally we do banking transactions on a daily basis or even a weekly basis, I don't know, whatever it is. So if you say you're going to go to a bank website, right? So what happens is that if you're trying to actually go to the web server, in this example, we have www.majorbank.se, right? So we would try to go to this bank, and then we have, just like what I mentioned you earlier, we have a resolver, DNS resolver, right? So this could be in a typical environment. This could be your ISP. So what happened would, you would go and do that query, right? Ask for the web server IP address, and then the resolver would go and talk to the DNS server, whatever, serving this bank website. And then the response would come to the resolver with the IP address of the web server, which is in this case 1.2.3.4. So you get the IP address, and then you can go and talk to the bank web server and get the web page, okay? So that's kind of general day-to-day thing we might do, right? And then once we get into the bank web page, we might see probably a login page. Say if you want to log into your account, you might see a login page there, and you would try to give your credentials, maybe your username and password and so on. And yeah, this is what we do, and then you'll get your account data, all right? So when this happens, now it goes all the way, it travels through the DNS tree hierarchy. Remember earlier I mentioned you, we have a proper structure. So the query would go to first to the root servers, and then it would actually refer to the next level servers, which is .se in this case, and then majorbank.se, and the DNS servers over there would give the correct response. So that's the normal path. Say again, you ask a question, and now with the caching process, we can get better performance always. That is also why actually, we would go for, we would try to do this, so that the caching servers or the recursive servers do not need to go and talk to root name servers again and again and again, right? So once this answer is kept in the cache for a certain period of time, until that period, until the caches expire, the caching servers can give the answer back. So in this example, you can see that there's no repetition between the DNS resolver and the DNS server because it's already in the cache. So it can straight away give the answer from the cache so that the clients can go and talk to the web server again and again, right? Multiple clients can come and talk to the web server and get the information. So, but say, what's the problem? What are the risks involved in this? Say we have a DNS resolver, same situation just like before. So we want to access our bank website, and we go to our DNS server. Now, before we really get the answer from the authoritative name server, right? If we, in a usual expectation, we are expecting that the correct authoritative name server would respond. But in the meantime, before that, if some attacker can respond back to the recursive name server with a wrong answer, say, so in a situation like this, right, then they can try to pollute or poison the cache. So now this wrong answer, in this example, the IP address 5.6.7.8, that's the wrong answer. The correct IP address is 1.2.3.4. Instead of 1.2.3.4, this 5.6.7.8 IP address will go and end up in that cache. Okay? So that will stay in the cache, and it will go back to the client. Okay? So that cache, so it will drop that, right? So this is actually the whole purpose or the idea behind DNSSEC and what we are trying to do here. Okay? And then we, anyway, ultimately get the correct answer, because the correct answer can be validated with DNSSEC. All right. So that's what we are trying to actually do here with the DNSSEC, right? So again, this is the validated answer back again, right? And it will be now, only thing is that what you need to know here is that these servers has to understand, because if they don't understand DNSSEC, this validation process cannot happen, and the signatures cannot be checked. So we have to make sure that they do understand DNSSEC. So that's the whole purpose. Again, this is kind of a list of, recent similar type of attacks as well, which happened. So the list goes on, and there are various hijacking type things, phishing type of attacks, and then even, spoofing and various things can happen, but we will not be able to detect that because unless we can really identify those or validate those. So what do you really have to do? I mean, say if you have to then implement DNSSEC, what are from a business case point of view, because you have to have some proper business case and make sure that you can really, this is a solution that where you can really go for it or implement it. Now, with the cybersecurity, with the rate of cybersecurity happening and so on, it is very important that we do consider some mechanism like this. As I showed you, even in the recent times, there were various incidents happen, and these are increasing. So this is why, from a kind of security perspective, we should try to go ahead with these type of infrastructure. Security infrastructures. In fact, in the recent times, you could call that DNSSEC is kind of the biggest upgrade to security infrastructures in terms of if you look at whole in the internet as a whole, right? So because DNSSEC has been there has been a lot of implementations in the recent times, especially in the root level, especially in the TLD level, and so on. These are, again, some of the statistics, I would say, especially from the deployment point of view, because sometimes you might wonder, okay, can we, what is really happening out there, who has signed, and things like that. So you can see that now, first of all, root has signed. So in the hierarchy, which I mentioned you earlier, so we have the root on the top, so root servers, root zone has been signed. If you consider the next level, which is the TLD, the top level domains, currently, we have 600-something TLDs. There are quite a lot, including the new GTLDs and so on. Out of that, almost close to about 500 or so, they have signed as well. 400-something or so, they have signed. You can see that. The root has signed as well, and as I said. Now, also, actually, from ICANN point of view, now ICANN do have agreements with the registrars and so on. And with the new registrar agreement, with the new one, DNSSEC implementation is it is included in the agreement. So that means when the new GTLDs, when they sign the agreement, it is a requirement for them to actually have DNSSEC. So these are some of the aspects that they can actually put some further attention to actually focus on DNSSEC and so on. Okay. Nowadays, also considering the next levels, there isn't much things happening below that level. So this is where we really have to push for DNSSEC. I mean, TLD level, you can see that it's all happening, it's all good. But below that level, say the ISP level, we can see some recent growth in the DNSSEC implementations of ISPs and so on. But still, we need more, right? We have to push more. There are third-party signing solutions as well. Even, usually the organizations would, if they want to actually go for DNSSEC, I've seen, people would first, try to have some in test environments. They would go for some manual type of implementations first, and then there are other implementations available. There are semi-automated type implementations available. There are fully automated implementations available as well, but they are costly, right? The fully automated ones. So always, we can start small. Okay, that's when, and then we can test it out and see how it goes. Okay. Yeah. So some statistics on the below the second level, which is actually below the TLD level. You can see it's very small percentage, only about like 2% or so. As a percentage, only have signed their zones with DNSSEC. Okay, many of them they do have plans, but it's very important to actually at least do some testing and so on. Now there are also actually mechanisms where we try to use DNSSEC kind of validations for other security mechanisms. Nowadays, we tend to use SSL, right? SSL. But the thing is that SSL is also not the best way. So we can try to actually have DNSSEC to do the similar function. So we have a protocol where there is some work going on, which is what we call DANE, right? DANE. So that's something which is going on as well. So we talked about the DNSSEC problem. So the current, we know what it's trying to do. We have these security issues. We try to protect those things using DNSSEC. But there are challenges as well. This is also why actually sometimes people, organizations, they might not really, take some actions, favorable to this. Especially not enough skills, or people don't know much about DNSSEC. This is one thing. So always it's a good idea to actually, make awareness about DNSSEC. And then sometimes some people also, they are a little bit worried about the performance issues and so on, because, the zones can grow, things like that. So these things can be some reasons, but there are, there are ways to at least, we can do some testing. We know then we can try to identify where the bottlenecks are, and then we can try to fix those as well. So the important thing is at least, start in some way, at least start with some testing so that we can try to do that. With the SSL certificates, the problem is that we have lots of CAs, right? There are lots of certificate authorities, so we really don't know, whom to trust. That's one big issue with the SSL. Whereas if we can come up with, proper DANE type of protocol, then there is a proper hierarchy, right? There is a proper hierarchy. There's only one root. And this trusting model is much better than SSL, for example. Okay. All right. So from a high-level point of view, what the organizations can do in this case, first of all, try to sign your corporate domain names, right? It is very important to do this, at least, as I said, start from small and do some testing, experimental, and then you can go into the next step. So try to, sign your zones, and then also, turn on the validation of your resolvers, the recursive servers, and so on, so that it can validate these answers. From users' point of view, it is important that they do at least get to the ISPs and demand this, because if there is some demand, then definitely there is some push from the user side to the ISPs, so they can try to implement as well. And in general, be aware of this thing. Try to even attend even training courses or tutorials, how you do these things. So these are all important to make sure that we are aware of such security mechanisms and so on. All right, so this is all about what are the risks involved and the current status, what's happening, and also what is being developed and so on. But let's now try to focus more on to the implementation aspect. So what are the things we need to know when it comes to the implementation? Now, to the DNS protocol, now we have to think about the resource records here. So when you have your zone files, we used to deal with lots of resource records with DNS, things like your NS records, SOA records, A records, and so on. But now when we work with DNSSEC, there will be some more resource records that you have to deal with, right? So there are a few resource records that we deal with. One is called RRSIG. That stands for Resource Record Signatures, RRSIG. Then also we have something called DNS Key Resource Record. Okay, and then also there is something called DS. I'll explain you the reasons behind these, and then NSEC records. Now, what we are trying to do, as I said earlier, we are trying to actually sign our zones. So when we sign our zones, we have to have keys, right? We have to have keys. So we need to first generate these keys. Now, probably you know about public key, cryptography, for example. But in DNS, this is quite similar as well. But in DNS, we are not trying to encrypt the things, right? We don't encrypt. So what we are doing is we are doing the signing process, so that when we get the responses, when we get the information, we know that it's coming from the right place. That's what we want to make sure, right? Not the encryption. So if we are going to have these keys, now in DNSSEC we use asymmetric keys. Now talking about asymmetric keys, what do you mean by asymmetric keys? You have public keys and private keys. They're different, right? So we have a public key and a private key. When you talk about symmetric keys, actually, they are pretty much shared keys, okay? So asymmetric keys, there are two keys. One is private, the other one is public. So if we have these two keys, so what are we going to do with these two keys? Private key, obviously, this is why we call it as a private key, because you have to keep it safe. It's your private key, right? So that's something private, so you always need to keep that private. And then the other aspect is the public keys. So public keys, you have to publish, okay? So public keys we publish, private keys we keep safe with us. So what are we going to do with this private key then? We are going to use this private key to sign our zone. So we have our zone, and then we will use this private key to sign our zone. So we need to go through some kind of signing process, right? So that we can sign our zone. When I say sign our zone means we are signing the zone data. So we have resource records. In fact, we have resource record sets, A records, and so on. MX records, and so on. So we do sign these resource record sets using our private key, okay? And when we sign this information, this data, what we get is a signature. That's why we say sign, right? We use our private key, and we go through a function, sign, and then we get a signature. Okay? So when we get a signature, we have to publish our signature, because if I'm going to give some data to you with my signature, right, that's where you have to check, oh, is this Champika's signature? I mean, how can I then know whether it is really Champika's signature? Then what you need to do is then you have to validate with my public key. That is why also I have to publish my public key. Okay? So I need to publish two things. One is my public key. So to publish my public key, I need a resource record. That's why I have this DNS key resource record. So DNS key resource record I use to publish my public key. And the next thing is resource record signature, that is to publish my signature. I have many signatures, right? In a zone, you can have many signatures. That's why you will have number of resource record signatures, or RRSIG resource records, number of those in a zone file. Now, next thing is, say I have signed my zone, I have published my public keys, I have, I have these resource record signatures and everything, that's fine. So I have kind of secured my zone. Is this enough? No, it's not, right? Now, as we know, DNS is a hierarchy, right? We have root, we have then TLDs, the next level, then we have, whatever dot something, the next level, and so on. So we have to then propagate this trust, right, along this tree hierarchy. So this is where, when you sign your zone, you have to propagate this trust to your parent, right? So you obviously you can trust your parent, and then you propagate the trust to your parent. So you need to, in some way, you have to send your public key to your parent, right? So that parent can get it, and parent can put that into their zone, and then sign their zone, right? So this is what we try to do. And then it has to go from parents to parent level, okay? So all the way up to the root, this process has to happen. So this is where we are trying to, do with what we are trying to do with this DNSSEC, and also this is the reason behind these resource records. So when you want to send that trust, how we do is we have this resource record called DS record, right? DS stands for delegation signer, and it is kind of a hash of the public key, basically. Right? So this need to be sent to your parent. So once you sign it, you get this DS record, it's a hash, and then you send this to your parent. So you need to have some kind of sending mechanism, how we want to send this to your parent. Also, we have another resource record called NSEC, or Next Secure. Now this is there to maintain the integrity of your zone, right? Integrity of your zone, as well as if there are, say, some records are non-existent, that can give the confirmation about those. Because, that is also something that we have to prove. If there is nothing, there is no record existent in our zone, we also have to prove that, right? So that is also where the NSEC comes in. So what NSEC does, it's kind of, have a kind of a linking process with your resource records, so that in case if the integrity is lost, we can try to identify that. So that's the whole purpose of NSEC. You don't need to do this manually, because during the signing process, these NSEC records will be inserted into your zone, right? Okay, so this is how, now DNS key, we know that DNS key resource record is there for publishing the public key, right? So if you have a look, now this is a typical example of a public key here, right? So you can see my zone, our zone is myzone.net, that's the zone, and this is our resource record type. Again, there are some flags here. Now these are coming from the algorithms we use. Remember earlier we talked about asymmetric key algorithms. So for example, if you use RSA SHA-1 kind of algorithm, then you would have a certain flag for that. So some of those flags, and then this is actually our public key. So this is the public key, and it has got a certain key ID as well. So that's where what we have to publish this DNS key resource record into our zone, right? So that's our public key. Now, how does the RRSIG? Now, RRSIG stands for Resource Record Signatures. I told you earlier, these are basically your signatures. So you use your private key to sign your zone data. So when you sign your zone data, what you get is a signature. And then what you need to do is you have to publish the signature in the zone. So how do you publish it? Using RRSIG. So how does it look like? It's something like this, right? So that's a RRSIG record. And then this has got some TTL here, just like before. It's a simple resource record, right? So you have the usual fields what we have in a resource record, things like a label. It has a label, it has a TTL, it has a type. All those things are there, okay? And then it has kind of a validity as well, because this is a signature, right? So from here to here, that's a signature. There is a signature for this particular record set, right? And it has got a validity. And so in this example, the validity is there for kind of 1 month if you really see, right? So because this is valid from, this is the year, month, and date. So year, month, and date. So you can see this November 2nd to December 2nd. So it has got kind of a 1 month validity in this case. Now this process is quite complicated if you really think about it, because you have to generate the keys, and then you have to actually publish your public keys, and then sign using your private keys, and then publish the signatures, all that. Now also I told you then you have to propagate this trust to your parent, which means you have to send this key to your parent as well. But the problem is, if you are doing more updates, say you are updating this key very often, if you're doing more updates to this key, which means you have to go and disturb your parent as well, right? Because you have to send the DS record to your parent, and then parent has to put that in their zone and then sign the parent's zone. So that's another process. So, so this can be quite, if you think you're doing a lot of updates and so on, one good solution is that you can have multiple key pairs, right? So this is where we have another type of key called a key signing key. Now earlier what we used was called zone signing key, or ZSK, zone signing key. So that's the usual key where we use to sign our zone. Now we can also have another key called key signing key, where we also, the signing process is pretty similar, just like before. But we can have a stronger key for this, because we can extend the validity of this, right? Because if we are going to send this key to our parent, we don't want our parent to, get disturbed every now and then. So we can include maybe a stronger key, and probably have a validity of maybe 6 months or so, longer validity, so that, we don't have to update that key very often. So this is why we have two key pairs, in fact, right? These are public keys, zone signing key and key signing key, right? NSEC. So that's the next thing, the NSEC record. So NSEC record, I told you that this is to maintain that integrity of the zone. So if you really see the NSEC, now these are all being inserted when you sign your zone, right? When you sign your zone, these are all inserted into your zone. So if you really see this NSEC record, you can see that it says what label is coming next, right? What label is coming next. And at the same time, it also says what other resource records you had before that. So this is kind of a link, right? And in the same way, if you see this NSEC record, it also says what label is coming next and what other records you had before. So this way, and also the last one will link back to the top. So in this way, it will link the whole zone resource record sets, right? So that's how the NSEC works. Now the DS. Now DS record, this is the one that we send to our parent, right? It's the kind of hash of our public key, basically, okay? And this is how it looks like. So we have the record type called DS record, and it has, again, these parameters come from the algorithms we use. And these are for 2 different algorithms, so we have 2 DS records in this case. Right? So we now need to send these to our parent so that parent can publish these into their zone. So example, like if I'm myzone.net, I'm going to send this to .net because .net is my parent. And then once the .net signed, they will have their DS records, and they will need to actually then send that to the root and so on. Okay. So DS. So DS we use to propagate that trust, and we call it as delegation signer, basically, DS. So we don't put the DS in the child zone, right? So this is something to know. We are always putting the DS record in our parent zone. About the validations, DNSSEC validations, recursive servers need to be enabled for validation, so that when the recursive servers or the caching servers, when they give these answers, they can give validated answers. Right? That's important. Now there is also a bit called AD bit. AD bit, right? AD bit stands for authenticated data. So if you see in the answers, right, you can see this AD bit. If you do a test, for example, dig and see, you can see if the answer can be validated, there is an AD bit set. Right? So you know that it is validated. Now there are also actually, there are a few other options. If you need a validating resolver, there are a few of those where you can install as well. So for example, you can install these in your web browser, basically. Okay. So what are the processes then involved in signing your zone? Say, if you want to do this whole DNSSEC signing process, what are the steps involved? First of all, you have to make sure that, as I said, you need to understand, your server has to understand DNSSEC. If there are some queries coming in, it needs to know that they are talking about DNSSEC. So for example, if I can speak 2 languages, if one person speaks to me in one language, I will respond back in that language. If another person speaks to me in another language, if I know that language, I will respond back to that person in the other language, right? So I can respond based on what people are talking to me, or which language they're talking to me. In the same way, if I understand DNSSEC, or if I don't, if I understand DNSSEC, if I get a question from a DNSSEC understanding client or query, basically, my answer will be DNSSEC enabled. In other way around, if the query, if the client does not understand, then I will give a normal response, just like, in a normal way. Okay, there's no any DNSSEC based answer, right? So enabling is the first step. You have to make sure it understands. And then the next thing is we need to create the key pairs. So we have to generate the keys. We can use some key generation utility for that. Okay, key generation utility, and then we can generate those keys. So for example, if you're using bind, you can use DNSSEC key gen, and then in this example, we can see that DNSSEC key gen, that's the utility we use. We are specifying an algorithm here. Okay, the algorithm we are using is RSA SHA-1. Okay. And we are also introducing a certain bit value. In this case, we are giving 1024 bits, okay? And then specifying my zone, that this is the zone that I'm going to do this, right? So I've created my keys, right? I generated my keys. And then next step is we have to publish our public key, right? Publish our public key. So during this key generation process, you will get 2 keys. One is your public key, and the other one is your private key. Private key you always keep safe. You publish your public key. And then after that, what you would do is you would sign the zone. How do you sign the zone? Using your private key, you would sign the zone. Okay? And once you sign the zone, actually, you will also see there's a new zone file will be created for you. We had we had our previous zone file. Now with our keys, we have signed, so we will have a new signed zone file. Now obviously this signed zone file will have lots of signatures, right? It has got a lot of signatures. So obviously, the signed zone file has to be much bigger than the original zone file because we have all those signatures now, right? And then what you need to do is you need to actually modify your configuration, because usually your in the configuration file, you would be talking to your normal unsigned file, right? So you need to replace that with the signed file so that the name server can read that signed file, okay? And then actually start the name server and then do a test, right? So these are the steps that you can do and make sure that you can validate those answers. So this is again, how the signing zone. With the new versions of Bind, there are different types of signing mechanisms as well. So DNSSEC sign zone, that's the utility again I'm using to sign the zone. I'm giving the zone, and these are again, my keys, right? That's the key. And then once you sign it, you will find another file. You can see it's with a .sign extension. It has got a .sign extension. And this file will have your signatures. And then you can do a dig. For example, in this case, you're doing a dig and looking for a certain response. Here we are trying to ask for the IP address of the web server, www.apnic.net. So we are asking for a DNSSEC enable answer. And so we should get the answer with the resource record signatures and the validity of those signatures. And then the next step is, of course, to push the DS records up, right, to your parent. So you can contact, usually the parent would have some kind of possibly a web interface or so. You can then provide your DS records to your parent, and then that can go to a database, and then the parent can probably pick from the database and then update the parent's own file, right? Simply, that would be the process. All right, so what are the ways to deploy then to have this process? Obviously, you can do a manual process. If you don't have a big zone, kind of simple one or so, you can do a manual process there. But it can be complex, right? It can be complex because you have to manage your keys manually, which can be quite difficult, managing your keys, because some keys will have expiries and so on as well. So you need to know the expiries and all that. So those are the complexities would come in. And then, I mean, for a static type of environment, that's all right. But again, this is cost effective. There's not really much of cost involved. Because you're doing it's a manual process, you don't have to get any other software solutions or automated solutions and things like that. Obviously, you will need to plan for kind of your performance and bandwidth and the even the zone files will be much bigger once you sign. All those things you need to have a little bit of planning as well. Okay. There are some other hardware security modules as well. We normally call as HSMs. And also there are some appliances, right? Boxes. It's all come in box. Everything is there. So it's everything is done for you. It's much easier to manage and things like that. Even key rollovers, you can do it in a very straightforward way. Again, those can be quite expensive, right? All right, so this is pretty much what we wanted to cover, right? So mainly from DNSSEC, what are the important steps, why this whole thing is important, what are the security threats what you have in case if you do not sign your zones, if you don't have DNSSEC implemented. Also, I talked about a little bit of status, where the root has signed, the TLDs, most of them they have signed, but the next levels we have to act upon and do, sign our zones and so on. And then also I went through, the implementation steps, but how you do it on a step-by-step basis as well. I can actually try to take about another bit of time and then try to actually show you, especially in how these keys looks like in a say, I mean, just before this, I ran a root server, right, and a GTLD server, and so for example, okay, this is okay. Now this is actually my .NET. So I was running just in a local environment. I was running a .NET server, okay, and then this is my root, right? I was also kind of running a root server as well, and then okay, this one. I also have another authoritative server, right, so that we can do some queries. We can run and do some queries and see how it looks like, okay? So if I actually go here first, that's my root server, right? So root server, I'll just show my root zone file. Oops, sorry. It's this one. Yeah, so this is my, so this kind of my root zone file, right? So in my roots, I mean, this is just a very simple one which I just created to show you a demo type of thing, okay? So that's my SOA, that's a root. So I have my name server, I'm just calling x.rootservers.net, right? x.rootservers.net. In the real life, as I said before, in the real life, you would have a.rootservers.net, b.rootservers.net, and so on, up to m.rootservers.net. I'm just using these IP addresses. I'm just using IP address 192.168.100.1 for the root server, okay? And then I have two delegations, one for .com and one for .net, okay? And they are running on, these are the name servers, .net. Actually, I'm running on x.gtldservers.net, okay? And then which has got the IP address 192.168.200.1. That's the IP address of my .net server. Okay, so I have root running on 100.1, and then .NET is running on 200.1. So if I go to my .NET, oops, sorry. So this is my .NET zone. So here you can see, now remember earlier in the root zone, root has got a delegation to .NET, right? Root has got a delegation to .NET. Now in the .NET, obviously, it has to refer to, now this is the root server, 100.1, and then I can have so many other delegations because below my level, I can have whatever .NET. Different organizations, they can have different delegations from me, anything .NET, okay? So these are all those delegations, and then I can actually have different name servers and the respective IP addresses and so on, okay? So these are for the .NET, and then, so let me actually run my root name server. Correct one? No. So this is my root name server. I'll just run my, okay, now before that, the first step, if you remember the first step would be, I'll go back to my .NET. The first step was, if I go back to that slide, the first step was to generate the keys, right? This one. The first step actually, you can say enabling DNSSEC. enabling DNSSEC and the validation. So if I see my named.conf or the configuration file, don't worry about many of these things, but if this is where I've kind of said I'm enabling DNSSEC, I'm validating DNSSEC here. Okay, so these are all my working directories where all my files are and so on. Okay, and then the next step would be to generate the key pairs. So when you generate these key pairs, you would give that utility DNSSEC, and then you give the algorithm and generate the key pairs. So when it generates the key pairs, actually it would give you two files. Now these files, right? Can you see there is a file with .key extension, and also there's a file with .private extension. So one of these set, and there are two keys. One is this 28572, and the other one is 42364. Remember we talked about two keys. One is zone signing key, and the other one is key signing key. So if I kind of open, say, one of these, 28.key. So this is what I have, right? So this one is the zone signing key, right? Is the zone signing key, and that's my public key, right? That's the public key, which I'm publishing this in my zone, right? And then also the other one, if I open, that's 42, this one. That's my key signing key, right? The earlier one was zone signing key. This one is my key signing key. And then again, this is my public key, all right? So I need to actually publish these in my zone. So this is why if I go to my zone file, if I open my zone file, I have put these two include statements, right? These two include statements. And what I'm basically calling those files. So in other words, I'm publishing my public keys, right? So the file with the .key extension has got your public key. So I'm publishing that, right? DNS key resource record. If you remember, DNS key resource record. So after that, then what I would do is now below my level, I also have my, say, the first one, right? Here again, if I go to my zone, db.net, you can see I have a delegation to this another zone called adam.net, right? Say, take this one, adam.net, right? And then I'm saying any query which goes to adam.net. Say if someone is trying to query www.adam.net, I'm saying go and talk to ns1.adam.net, ns1.adam.net. That's basically my delegation. So remember, when the query resolves, it goes to the root and to .net and then to adam.net. So I need to refer, if I'm .net, I need to refer to adam.net's name server, which is ns1.adam.net. Right? So that's where they would have in their zone file, they have to again have those zone records and so on, and then they have to sign that zone, and then in the same way they have to do the signing and then send the DS records to myself, right? Because I'm the parent, which is .net. So that's why you would find I have these DS records that I've got from adam.net, right, my child here. So I have published those in my zone, so adam.net. These are the DS records for that, and these are actually those hashes for that public key, which actually came from adam.net. So it's published now in .net, and then I have sent my key, of course, to the DS record, of course, to the root. Right? So this is how the whole chain gets built up, basically, right? And say now let's try to start these name servers, okay? Also, now, actually, during signing process, you will also see this db.net signed, right? That's the signed zone file. This is my normal zone file, db.net. See, if you see db.net, if I open db.net, you don't see any signatures, right? You don't see any signatures. Whereas after signing, if you see my db.net sign, this will be created, db.net sign file, that has got all these signatures because it has gone through the signing process. So you can see the RR6, you can see all those NSEC records, remember we talked about, and all those things, right? So obviously this file has grown much bigger than my normal file. You can even do a bit of comparison here. If I just try to compare those two files, say have a look at these two, right? This versus this. db.net versus db.net signed. So that's, yeah, so this is like 1462, whereas this one is some 8 something, right? So it has grown almost, number of multiple times. I mean, my zone is a very simple, only few records, that's it, right? But in real life, if you have a big zone file, that can be quite big after signing, all right? And then the other thing what I wanted to show you, the DS. So when you have this signing process, you will have this another file called DSSEC. Basically, this is your DS records, right? Your DS records. These are the ones that you need to get and give it to your parent, right? So if I'm, the something myzone.net, I will get this and give it to .net, right? So these are the DS records. So let's try to kind of, run these name servers. I'll just run it in foreground so that you can see the messaging and all that. So now you can see my .NET is running. So you can see it's DNSSEC signed, okay? And its zone is loaded, right? And I will also actually run the root as well. So that's fine as well. You can see now root is loaded, DNSSEC signed. I've also actually put a trusted anchor as well. So I will also run this name server. This is actually adam.net, right? Adam.net. Oops. No, actually it's inside. All right, so you can see adam.net is also signed now. And don't worry about some of these things. Some of the other zones have expired, but mostly have a look at this one, right? So adam.net, that is what it is signed. Now, actually, if I do a query, say, I can ask for give me www.adam. Okay, I'll look for, because I'm running my name server here, so I'll look for my local host. Okay, I got this answer. So you can see that I was asking for www.adam.net. I was looking for the IP address of that, and I got this. This is the IP address of www.adam.net, right? And so that took 73 milliseconds because the query went to root and then to the next level, which is .net, and then adam.net, and I got the answer from adam.net. All right. Now, if I do this query, nothing to do with DNSSEC. It's just a normal query. Even though it's all understand DNSSEC, it just responded without any security in place, just normal answer, right? So even if some client is asking a normal query without DNSSEC enable, it will answer the same way. But if I do a query now, say, with DNSSEC enable, the same query, I'll just kind of, properly format that. So if I ask with a DNSSEC enable query, all right, so now you can see that I got with the signatures, right? I got with the signatures, and most importantly, have a look at this one. The AD bit is set. ADBC set means it is authenticated data, right? So that's where I can rely on this answer. I know that www.adam.net is the right web server. That's the right place. I'm not going to some bogus fake website. Okay, so that's pretty much how it would work, right? So I think that's what basically I hope that you got some idea about this DNSSEC and then the signing process, what you need to do and send the keys and so on, right? Hopefully this would be a good start in case if you haven't tried this before, probably to do a little bit of testing at home and give it a go, right? Any questions? No questions? All right, I think probably we are on time, I guess, and hopefully the content was useful to you. And if you have any questions around, maybe later on and so on, I'll be around as well. Feel free to have a chat as well, and we can talk more. Okay, thank you very much, and thanks for your time today.